The pectoral girdle, which attaches your arms to the skeletal rest of the skeleton, is actually made up of two different bones. This one here, shaped like a triangular, is the scapula. It's also called the shoulder blade. The other one over here is the clavicle or collarbone. We'll look at these two bones in detail, and then we'll take a look at how they fit together to form the complete girdle from which your arms are attached. The clavicle is an S-shaped bone that lies horizontally at the upper border of the chest. The front and upper surfaces of the clavicle are smooth, like you can see here. The lower surfaces, the inferior surfaces, as you can see, are roughened. These roughened edges here are because of all the muscle attachments, that occur in here. Now, the flattened end looks like this. This is the part that's going to attach to the part of the scapula called the acromion process. This portion over here is going to attach to the sternum, part of the bony thorax. This is the only point of attachment of the entire pectoral girdle to your skeleton. So if, for example, the clavicle were to break, there would be no support. So your arm would just kind of fall in towards the chest. And that's many times the way you could tell if the collarbone has been broken. Does their shoulder drop towards the midline of their chest? The scapula, which you see here, is a triangular shaped bone that lies against your back. This smooth flat surface here lies across your back, and it extends from the 2nd to the 7th ribs. Now, it doesn't directly attach to the ribs, otherwise the scapula would not be able to slide back and forth, and you wouldn't be able to move your arms forward and backward. Like if you try and do a row, you couldn't be able to pull your arms back. The back side of the scapula has this huge spine that runs down. Now, the prominent features that you would have to know, for this class, are the very top up here, top of the spine. This is the acromion process. If you reach up and feel the bump at the top of your shoulder, the point of your shoulder, that is the acromion process. Another process you'll need to know is this one right here. For the other view, from the front view, right here. This is the coracoid process. Different muscles and ligaments will attach at this point and help move your arm. Now, the third thing that you really should notice here is this point right here, this circular depression here. This is the glenoid cavity. Now, this is the point where the humerus will attach. Now, one of the reasons that the shoulder is so flexible and at the same time so unstable is this. This bone coming in here is the humerus. Now, the humerus will attach to the scapula like this. Now, you can see how shallow that attachment is in there. But it also provides for all kinds of movement of the humerus in and around. This is why it's so easy for us to reach above our heads to grab things and hang. But it's also the same reason that it's so easy to dislocate, because this is not very firmly attached into the glenoid cavity. So a shoulder dislocation occurs really quite simply. Now, the upper arm bone is called the humerus. Now, the humerus has the head, the shaft, and the distal end. We're going to look at several features on here, close up and personal, so you can learn how to identify this particular bone and how this is going to work to function. First, look at the head. This is the part that inserts into the glenoid cavity of the scapula. Now the head has a very small little region right here called the anatomical neck. Now when you look at the femur, there is a much greater neck because the head's going to go further in the femur. The head goes much further into the pelvic bone for support and stability. Here it's very shallow. Now attaching muscles to these points, you have a very large bump here. This is the greater tuberosity. The smaller bump, the lesser tuberosity. And between these is a nice little groove here where the biceps tendon comes on through. You know, attaching the bicep muscle to your scapula. Now at the distal end of the humerus, you see two distinct features. First of all, this rounded head called the capitulum. This is the point where the radius is going, the next bone down in your forearm is going to attach. Also, you have what looks like a little pulley right here, and Latin for pulley is trochlea. Now you also have two bumps on the ends that you can see from here. These are the epicondyles. This one right here on the inside is the medial epicondyle, and the one on the outside is the lateral epicondyle. Now when you look from the posterior surface or back side, you can see those condyles much better. Here again is the medial epicondyle and lateral. Now here's where the trochlea is at, and this is going to be where the next bone of the forearm, there's two bones of the forearm, I mentioned one already, the radius, but the ulna is also going to come around in here. Now there's a part of the ulna called the olecrayon process. The olecrayon process is going to fit into this little groove right here, this little hollowed out region on the back part of your arm. This is called the olecrayon fossa. Now, you have two bones that make up your forearm. Going from lateral to medial, you have the radius. And a good way to remember the radius is you got a rounded end. And every circle has a radius. Medially, you have the ulna. Good way to remember this one is the little hook-like portion right here. It looks like the business end of a monkey wrench. Because it looks like a letter U, should help you remember that is the ulna. Now in positioning these bones, going from lateral to medial, the bones are in alphabetical order, so R before U. Should be an easy way to help you remember those. Now the radius attaches to the humerus at this rounded portion we saw earlier called the capitulum. It fits right in here, and because of its round surface here, it slides back and forth. It pivots. This is going to enable you to take your hand from a palm up position, like this, palm down. Okay? Now, attaching, notice a big bump right here. This is the radial tuberosity. This is the point where the bicep muscle attaches to the radius and is responsible for flexing your arm. Now the other end of the radius, you have a little point out here. This is the styloid process. This is the bump you feel on your outside of your hand. If you sit there, palm up, reaching out, the styloid process is going to be right here. You can feel this bump here. Now the ulna also attaches to the radius at this little point here, the U shape called the trochlear notch. Now, this end back here is the olecrayon process. So it'll fit right in here. The trochlear notch fits into the trochlea. So now your elbow bends this way. And like I showed you on the previous there, the olecrayon fossa is a nice little spot here where the olecrayon process fits into. Now also on the ulna, you'll have ulnar tuberosity, also on here. This is where another part of the bicep muscle attaches to still assist in flexing your arm up. And just like on the radius, you'll have a bump on the outside. This is a styloid process. They're both called styloid processes, whether they're on the ulna or on the radius. On your wrist, the big bump on the outside here, same size as your little finger, that bump right there is that styloid process. Now the bones of the hand are similarly named as the bones in the foot. Now in the bones of the hand, you'll have these bones here, the wrist bones, the carpal bones. They're going to be basically pivot joints to allow your wrist to move back and forth. Attached to your carpals are the actual hand bones through here. These bones here are the same as these bones here. These are the metacarpals. The prefix meta means beyond, so if these are the carpals, beyond the carpals are the metacarpals. The remaining bones beyond the metacarpals are the phalanges. On your hand, the little finger, the ring finger, the social finger, and your index finger are all basically made up of 3 separate phalangeal joints. Your thumb only has 2 phalanges.